Hi friends, this is Mrs. Hahn. Today we're going to be talking about area models and the standard algorithm and what's the connection between the two. This is lesson 6 and 7 combined. It may feel like a lot. I'm going to go through 3 problems today. Each one levels up with a new added amount of digits in the factors, and you're going to get a whole bunch of practice. To get the best out of today, I need you to follow along in your math notebook. That way you can take notes and you have the record of the notes while you go off to do your own work so you can look back to see what we did. Remember, you can always pause the video, replay it, or even watch it over again so that you can make sure that you are able to complete your problems independently and on your own. You can pause the video now if you need to go get your math notebook. All right, welcome back. Glad you're ready to go with your math notebooks. The first problem we're going to be working on today is 64 times 73. This looks very similar to the problems we've done last time we were together, except neither of these factors have a 0 at the end, telling me that neither of these are a multiple of 10. So that means we just need to decompose a little bit differently to build our area models. So I'm going to start by building a large square, just like any other area model you're used to. Make sure you leave side off to the right so that you can do the standard algorithm. And it does not matter which factor I put on which side, because as you know, with our commutative property, we can rearrange factors in a multiplication problem. I'm going to just choose to do 70 on top and 3 over here. And then I'm going to break apart 64 on this side. Go ahead and build your area model. And like I said before, it does not matter which way you put your factors, but the one thing that does matter is that whatever number you put on top is the same number you put on top in your standard algorithm if you want them to match each other. We know we're going to get the same answer no matter which direction we do it. However, lining them up the same order on our area model and our standard algorithm helps us so that we can see the parts that match later. All right, let's go ahead and start filling in the area on our area model. For this area model, I'm going to go ahead and write the equations. On the next few examples, I won't be doing that. So I'm going to start right here in the corner, 4 times 70. And I know that I can solve this by doing 4 times 7, then times 10. So 4 times 7 is 28, times 10 is 280 when I slide it over one place value. Next box over here, I'm going to do 4 times 3, and we know that as a fact, and that is 12. Next down here, we're going to do 60 times 70. This is the same as 6 times 7 times 10 times 10, or 6 times 7 times 100. 6 times 7 is 42, times 100 is 4,200, or 4,200. And finally, in my last box, I'm going to do 60 times 3. That is the same as 6 times 3, which is 18, times 10 is 180. If that was too fast for you, pause the video, go back, play it over again so you can get this all filled in. I'm going to move on next to our standard algorithm. You know that we start in the bottom right-hand corner with the ones, just like we did in our area model. So first I'm going to do 4 times 3 is 12, and in my standard algorithm I regroup the 1 to the tens place because that's a 10 in the number 12, and I'm going to put 2 in my product area in my ones place. Then I'm going to do 7 times 4, which we know is 28, and I'm going to add in this extra 10, so now I have 28 tens, which is the same as 280, and then there's a 2 in the ones place, 280. Or 28 tens. Sorry, I meant to write that down. 29 tens. 4 times 7 is 28 plus 1 more is 29. And now I'm going to go down here and do 6 times 3, which is 18. And it's in the tens place, so it's really 60 times 3, which is 180. 6 times 7 is 42, plus 1 more is 43, or 4,300. Now I'm ready to add. Before I do that, I'm going to come back over here to my area model, and I'm going to add up my areas going across and going across so that I can add them together so it looks like this. 280 plus 12 is 292. I can do that problem in my head. 4,200 plus 180 is 4,380. And now I can add those down and find the total area of my box. And you might have noticed that this total, my partial product, is the same as this part in my multiplication standard algorithm. That's because in this line, I did 4 times 73, and in this line, I did 4 times 73, which is 290. And this is the same here, 4,380, because I did 60 times 73, which is the same as I did over here, 60 times 73. Now I'm going to just go ahead and add straight down. 2 plus 0 is 2. 9 plus 8 is 17. 2 plus 1 is 3, plus another 3 is 6. And 4,000. Double check down here. 2 plus 0 is 2. 8 plus 9 is 17. 3 plus 3 is 6. And then bring down the 4. 4,672. 4,672. They match. Good job. All right. The next problem that we're going to model is 814 times 39. Go ahead and get that set up on the next clean page or the next large area of your math notebook. All right, so the only difference that you'll notice between this problem and the last one we did is that one of our factors has 3 digits instead of 2. I'm going to set it up the exact same way. I'm going to make a large box. I'm going to make this one a little bit larger because I know I have more place values. I'm going to try not to squeeze over here too much. And then I'm going to set up my standard algorithm, 814 times 39. And if you remember, because I put 814 on top, then I need to put 814 on top of my standard my area model. 810 and 4. And then 39 over here on the side. Okay. And last time I told you that I was not going to be switching to write my factors in the boxes. I'm just going to write my products. So 9 times 800 is the same as 9 times 8, which is 72, times 100, which is 7,200, or 7,200. Next, I'm going to do 9 times 10, which is 90, and then 9 times 4, which is 36. Again, if I'm moving too fast for you, make sure you pause the video, slow it down, choose to replay it after, or watch the whole video straight through. You have control of this. My next section of my area model is 30 times 800, which is the same as 3 times 8, which is 24, times 10 times 100, 4 times 1,000, because 100 times 10 is 1,000. So I'm going to slide it 3 place values to get 24,000. Next, in my area model, I'm going to do 30 times 10, which is 300. 30 times 10 is 30, and slide it 1 place value to show times 10. And finally, I have 30 times 4, which is 3 times 4 is 12, times 10 is 120. Now, I'm going to add these up in my head going across. And I'm going to start with my smaller numbers because I know that 90 is close to getting to 100. 90 plus 36, I need 10 more to get to 100. So if I take a 10 out of here, I have 126. 7,200 plus 126 is 7,326. And 300 plus 120 is 420, 24,420. And again, you can see my numbers are getting squished over here. They're not quite lined up the way I usually like to have them, but that's okay. I'm going to wait on adding this so I can go through and do my multiplication over here. 9 times 4 is 36. 9 times 1 is 9, plus 3 more is 12. 9 times 8 is 72, plus 1 more makes 73. I'll cross these off because I've already used these. 3 times 4 is 12, but I'm in my tens place, so I need to make sure that says 120 is 30 times 4. 3 times 1 is 3, plus 1 more is 4. And 3 times 8 is 24. And now I'm ready to add. Before I do that, I can see if these match. 7,326. 7,326, that is the product of 814 times 9. 814 times 9. And 24,420. 24,420, those match. This is the product of 30 times 814 and 30 times 814. Looks like I'm good. Everything matches. So now I'm going to go through and add. 6 plus 0 is 6. 2 plus 2, 4. 3 plus 4, 7. 7 plus 4, 7 and 3 make 10, and 1 more is 11. And 3. Okay. All right. And then I'm going to go over here and add over here. 6 plus 0 is 6. 2 plus 2 is 4. 3 plus 4 is 7. 7 plus 4 is 11. And then 2 plus 1 is 3. 31,746. My products match. All right. Pause the video here if you need to catch up. All right, and we're going to move on to our very last example. We're going to do 524 times 136. As you might have noticed, we now have a 3-digit number times a 3-digit number. All that means is it takes up a little more space and there's a few more steps, but when we break it down, we can do anything. We can do 8-digit numbers times 8-digit numbers. It just takes a little extra time to build all the steps. All right, make a bigger area model here. And I'm going to put 524 on top just because it's the first one. Again, it doesn't matter which order we go in as long as you just make your models match. 524, 524, and then 630, 100. Okay. All right, so same thing. We start in the upper left-hand corner in an area model, and we start in the bottom right-hand corner in the standard algorithm. However, it's the same digit that we're starting with, 6, 6. Again, we can pick whichever order and fill these in randomly, just as long as we get there in the end. But so that it matches our order, I'm going to go in the same order for each problem. 6 times 500. 6 times 5 is 30, times 100 is 3,000. Then we have 6 times 20. 6 times 2 is 12, times 10 is 120. And 6 times 4 is 24. I have 30 times 500. 3 times 5 is 15, times 100 is 1,500, times 1,000, times 10 is 15,000. 30 times 20. 3 times 2 is 6, times 10 times 10 is 600, or times 100. Notice how I'm paying attention to my zeros and my place values. And finally, 30 times 4 for this row. 3 times 4 is 12, times 10 is 120. And this last row is going to be easy because I'm doing everything times 100, which means I'm just sliding each of these partial factors into sliding it 2 places to show 100. So 500 times 100 is 50,000. 20 times 100 is 2,000. And 4 times 100 is 400. All right, since I have a little tiny bit of room here, I'm going to write a little bit smaller for this one. I'm going to do 3,000 plus 100 plus 120 plus 24. 20 and 24 is 44. So I have 3,144. 3,144. I am going to keep 2 my boxes so I can stay nice and straight here. And put my comma right there to show thousands. 15,000 plus 600 plus 120 is 15,720. So 15,720, making sure that everything's nice and lined up. And 50,000 plus 2,000, 52,000 plus 400 is 52,400. And again, I'm going to wait to add these until I do this part. And as you might have noticed in the last 2 examples, that however many digits are in the bottom number of my standard algorithm show me how many lines I'm going to be filling in. 6 times 4 is 24. 6 times 2 is 12 plus 2. Is 14, sorry. I went ahead and did it, but didn't say it out loud. And 6 times 5 is 30, plus 1 is 31. So 3,144. Cross these off. Now moving on to my tens place. Some people like to put their 0 in first. It doesn't really matter. Nobody will know which one you did first. I like to do it after, but some of you who like to do it first will do it first right now. 3 times 4 is 12. Or 30 times 4 is 120, and it forces me over a place value. 3 times 2 is 6, plus 1 more is 7. 3 times 5 is 15. And finally, this last one, I'm not going to do it the way I would normally do it in the standard algorithm because I know this is a 1, so I know everything's going to be the same. 524 times 100 slides this number 2 places to the left. So I'm going to go ahead and put my 2 zeros in and then write 524 with 2 zeros, which is 52,400 because I slid it 2 place values. So now I'm ready to add. You can see that I have matches, 3,144 15,720, and 52,400. Perfect. All right, 4 and 2 zeros is 4, 6, 12, 8, 9, 12 again. Oh wait, sorry. 5 and 3 is 8, 9, 11. Sorry, it's 11. And 5 and 2 more makes 7. 4, 6, 71,264. Sorry, these get squished. I wrote too close together. Hopefully you didn't write too close together. 71,264 matches for both. All right. So now your job is to go into your red Succeed book. On page 105 and 106 are problems just like this for you to do for homework. Pro tip, use the homework helpers if you get stuck, or since you are so smart and followed along in your math notebook, you can look in here. Look back at your own notes. Look back. All right.